Content objective. You'll be able to apply geometric theorems and properties to prove two triangles are congruent. We'll still be using the postulates we've seen: side, 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 and angle, side, angle. Here's some steps you should follow when doing proofs. Use the given information to mark congruencies, right angles, parallel lines, etc. on the given diagram. If vertical angles are present in the diagram, then presume that these angles are congruent. We know that vertical angles are congruent. We can mark those also. The first statement in your proof should be the first given, and the reason is given. You'll see that in a little bit. Deduce all possible information from that given until a conclusion is reached. Continue with the next given and repeat step 3. If you have used up all the givens and you do not have triangle congruencies, look for reflexive side, reflexive angle, or vertical angles to get a congruency. Once you have 3 congruencies, determine if the triangles are congruent by our 3 theorems: side, 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 or angle, side, angle. Your last statement should be the prove statement, and your reason should be one of the postulates: side, 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 or angle, side, angle. So let's see how this works in a 2-column proof. So in example 1, we're given 2 pieces of information. The first one is side AD is congruent to side AB, or segment AD is congruent to segment AB. So that's going to be our first statement. And on this side, on the right side, are reasons for this statement. So this reason for this first statement, it's given information. So we go ahead and put this into our picture. So AD, we'll put a congruent mark there, is congruent to AB. So now we already have a side that's congruent. I'm going to put an S here to remind me I've got one side. So that's all we do with the first given statement. So now we're ready for the second one. DC is congruent to BC. Again, this is the reason is it's given information. So we'll mark those with 2 marks. DC is congruent to BC. We've got another side. And again, these are a little bit easier when they put in some things for you. So they've already put in the next statement: AC is congruent to AC. Yes, and if you remember, this is called the reflexive property. That is the reason we can write that statement, okay? The reflexive property. Now again, as I said earlier, the last statement in a proof, and this is going to be the last, is to state the prove part. So now we're ready to prove, because we have 3 sides that are congruent in each of these triangles. That triangle ADC is congruent to triangle ABC, and the reason again is side, side, side postulate. We had the 3-side congruency. Okay, so there's a little start to what we're going to be doing. We've got statements on the left side and the reasons for each of those statements. The given information goes first, and then the prove is the last statement. So we look at our next example. The first given statement is, I think they put these out of order. They put the second one first, which is C is the midpoint of BD. Again, that's given information. Now I'm going to go ahead and put this another one. We've got it. C is the midpoint of AE. That's given also. So what do we do with this first one? If C is the midpoint of BD, what are they trying to tell us? So C is right here. It's the midpoint of this segment right here, B to D. Well, if it's the midpoint, then we know that these pieces are congruent. Okay, so we mark them congruent. And that's going to be our next statement, I believe, is to say that BC is congruent to DC. And the reason is definition of a midpoint. Okay? If this is the midpoint, then what? It splits it into 2 equal pieces. Same with the second one. If C is the midpoint of AE here, then these pieces will be equal. This one to this one. And they started it. They said AC is congruent to what? CE or EC, either way. And again, definition of midpoint. Now we can see we got two sides and part of this is filled out, and definition of vertical. Yeah, if we get this angle right here, it will be the included angle. And that's what we need here. And so we're going to say this angle is congruent to this. We'll see how we wrote it with the three letters because they have the same vertex. So the one on the left is ACB, and the angle on the right is E to C to D. So now we have two sides and an included angle congruent to two sides, included angle of the other one. So here's the prove statement. Triangle ABC is congruent to EDC. That came from right here in the prove part. And what is the postulate? And that was, it's not there. Uh-oh. So I better put it in. Side, angle, side. Okay, there's a couple of them. We saw how midpoint comes into play. When they tell us the midpoint, they're trying to tell us two pieces are equal. Okay. Again, we had the vertical angles come in here. Let's take a look at the next one. Now we get a little tougher. We'll see what's happening here. But they've got filled out, and we're going to have reasons. So this first statement, what is the first statement? Is always given information. You can see it up here in the given. And what's next? Another given statement. Let's see, let's mark those. HY is congruent to LY, this one. The next given is what? What did they give us? They gave us the parallel line. So this is read WH is parallel to LF. And you'll see there's nothing we can mark right now in our picture. But if these two are parallel, I'm going to highlight them a little bit. HW is parallel to FL. So here's our parallel lines. We're going to be looking at parallel lines cut by a transversal. We will also see that they don't actually get the right angle they need here, but we're going to go ahead and do it anyway. So if we look at angle HWY, H to WY is this angle right here. And it's congruent to something. So I can see if I take and cut these parallel lines by this transversal right here. This is an interior angle up here. And alternate interior angles are congruent from the lessons we've learned before. So this is its alternate interior pair, and that's what we're going to put in here. There's their reason, alternate interior angles for this one. In a minute you'll see that's not the one we need though, and I'll show you the one we need. Again, this one would be LFY right here. So these are congruent. And then what do they got next? And they have these two angles. Okay, let's see let's mark those. I'll have to go back. I erased too much in the picture. So we had HY was congruent to this, and then we just saw this angle is congruent to this one, alternate interior angles. And then they tell us these. We got to come up with a reason. HYW, which is this angle, is congruent to LYF. LYF is this one right here. And hopefully you remember that these are vertical angles, and vertical angles are always congruent. But if you look at this picture, we do have two angles in a side, but it's not the included side. Okay? It's because they did the wrong angle right here. We're going to show you that H and L are congruent. I named them with three letters, WHY. WHY is this one right here. I'll put 3 marks there. and FLY. F to L to Y is this one right here. And these are congruent by the same thing with those parallel lines. Whoops. If these parallel lines are cut by this transversal, we'll see we have alternate interior angles in here. But now it gives us angle, side angle with the two angles on the included side and the two angles on the included side over here. So they made a mistake in these notes. This was the angle we really needed. And it still came from that parallel lines cut by a transversal. So what I want you to remember in this is when they give you two lines are parallel, you're going to be looking for, there's two possibilities. You know, either alternate interior angles, like we saw twice in this one, or there's possibly, we're going to see it in a little while, corresponding angles, which are congruent also. Okay, so you got to get the right reason. Are they alternate interior or corresponding? Are the only two I've seen so far. All right, our last thing was the prove statement. They put it in there. And again, it was by angle, side angle for this one. Okay, if you have any questions, you let me know. All right, here we go. Next quick check. We'll start with this given information. B is the midpoint of AC. I'll show you how I do this a little bit too. All right, and the reason, of course, is given. So we're going to go ahead and now what can we mark in our picture since that's the midpoint? So here's B again. It's the midpoint of this segment right here. So it splits it into two equal pieces. So we know this piece or this side of the triangle equals that one. Okay. So we'll go ahead and say that now. All they told us was midpoint. So now we can say these two pieces are equal. AB is congruent to BC by definition of midpoint. Okay. Next, instead of going to the parallel, I like saving that given information for last if there's something else. So I'm going to write this given information. BD is congruent to AE. Again, the reason it's given. So I'll mark it in the picture. BD, this piece, two marks this time, is this one. So now we'll go to the parallel, and the reason I'll show you, the reason I save that for last. So BD is parallel to AE, that's given information. All right, remember that when they give you parallel lines, you know, we're dealing with, they're trying to tell us some angle is congruent. And if I look at my picture, I can, you know, kind of guess or hope which one's congruent. Because I got two sides here, and if I'm going to get an angle, I want this angle right here. It's the included angle, angle 1. And same over here, it will be angle 2 would be the included angle here. And yes, if you draw those parallel lines in, this parallel to this, we can see we have 4 angles up here. You can forget about this line right here. And 4 here. This is an exterior angle, this is an interior. But if I look at it closely, these are corresponding angles. And this is in the top right of these 4 angles, and this is in the top right position of these 4. These are corresponding angles, and corresponding angles are congruent. So now I can say angle 1 right here, put a 1 mark, is congruent to angle 2 because they're corresponding angles for parallel lines cut by a transversal. Okay? So there it is. Now we have our side angle side congruency. We can go ahead right to the proof statement, which comes from right here in the theorem right here. AB is congruent to triangle BCD, and again it was side angle side. That is the reason for that. Alrighty. Zooming right along to example 4. Here's something new in this one. This symbol right here, we'll go ahead and put that as our first given. How does that read? Segment BA, we'll look at it in the picture. This segment right here is perpendicular. This upside down means perpendicular to YZ here, which means it intersects at a right angle. So these are right angles, 1 and 2. Now so they put that next. 1 and 2 are right angles. Why is that? Definition of what perpendicular means. It intersects at a right angle. So then they went on to say, okay, well, if that's true, then angle 1 and 2 are congruent, right? All right angles are congruent. So we got one congruent angle so far. Next, we go to the next piece of given information. BA bisects angle YBZ. Bisect means to cut in half. So there it is, right there is a statement. We'll put that as given. So it's cutting this angle in half, YBZ, this big angle. So that means angle 3 and 4 are congruent. Cut them into two equal pieces. This angle equals this angle now. So we go ahead and put that down. They got it here. Angle 3 is congruent to angle 4 by definition of what? Angle bisector. Cuts it in half. And the last thing, they have AB is congruent to what? Well, if you look at our picture, AB is this shared side. It's congruent to itself. So we'll mark this with a 1 mark. So AB is congruent to segment AB, the reflexive property. Now you can see from our picture I have an angle, a side, and an angle. And it is the included side for these two angles. It is the side that touches the vertex for both of these angles, okay? And joins them together with a segment. So there's our proof statement, and again it's angle, side, angle. All right, a couple more, and then we'll go ahead and practice them on your own. So we start with the given again. BA is congruent to ED, mark it in our picture. BA is right here. ED, so we got a side so far. Again, the reason for that is given. Then we go to the next given. I'm going to save the parallel for last. I'll go to the C is the midpoint of AD. That again is given. So again, when they tell us it's a midpoint, then there's two equal segments. So it's this long segment right here is cut in half by this. So I know that this piece equals this one. So we have two sides now. We want either a third side or the included angle. Okay, so if I look at this and hope, I want this one really is congruent to this one. Why? Because the next given is about parallel lines. And I know, AC, DC, yeah, there was that given. This comes from definition of midpoint. Now I put that last given, that they're parallel, given. And again, I want these angles right here. So if I look at these parallel lines, and look where the transversal would meet those angles right here, this one right here. And now I can see they're alternate interior angles. Yes, and alternate interior angles are congruent. So I can say this angle A is congruent to angle D. And I named it BAC and EDC, but you can see the middle is A and D there. You can look at your picture and check that. And again, those were alternate interior angles are congruent. So now we're ready to prove these. We've got side angle side, side angle side over here. So the proof statement is right there. Triangle BAC is congruent to EDC by side angle side. All right, the last one is a quick check here. Some of it's filled in for us. So the first statement, they're parallel. That is given. And then what two angles are congruent, are alternate interior angles congruent? So there's really two sets. If I look at, let's see, AB and DC. AB and DC here. And I cut it with this segment right here. There's actually, let's see, it would actually be 1 and 2. Okay. On this side, no, it's not 3 and 4 because on this side it's not just this angle 3, it's this angle 3 plus this missing piece here. Okay. So we're not marking those. We're marking angle 1 and 2 right now. I'll erase this mess in just a minute. So because these are parallel, angle 1 and 2 are congruent because they are alternate interior angles. We'll clean this picture up in a second. I'll go to this next given a statement. These two are parallel, AD and BC, given information. So let me clean up my picture a little bit. We do have 1 and 2 congruent right now. Now if you look at AD, which is this line, is parallel to BC here, and you cut them with this transversal here, we can see that now 3 and 4 are congruent. We'll put 2 marks there. Alrighty, so that's why they got 3 and 4 are congruent, and what? Yes, they're alternate interior angles again. On different sides of the transversal, they're both interior inside these 2 lines. Alright, and now the reflexive property is that side that's common to both. Okay, so I'll mark that with 1 mark right here. So we can see we got angle, side, angle in each of the triangles. It is the included side. So we'll go ahead and do our reflexive property. That was side AC is congruent to itself. And now we're ready to go right to the prove. And again, the reason is angle, side, angle. Okay. Let me know if you need any further explanation on these. Otherwise, get caught up with these notes and the practice that goes along with them. Give them a try. Let me know if you need a little help. Good luck. Ew, I got another quick check. Whoops, we're not quite done. Let's go ahead and do this one. There was example 5 and this quick check. So let's look at this one. First given information is angle Q is congruent to angle S, given. We'll mark those. Q right here, S. R is a midpoint of QS, so R is in the middle on this segment QS, so we know it splits it into congruent pieces. So there's the fact, the given information, it's a midpoint. So QR is congruent to RS, the definition of midpoint. And then angle PRQ, let's see. P to R to Q, yes, that's this angle right here. Is congruent to the angle TRS. TRS is this one right here. And why are those congruent? You guessed it, vertical angles are congruent. Those are vertical and they're always congruent. So now you can see from our picture it's marked. We got a side, an angle, and a side. That's the included side also. I'm sorry, an angle, side, angle. And over here we have an angle, side, and an angle, and it is the included side for those 2 angles. So these 2 triangles are congruent by angle, side, angle. All right, give it your best. Remember, when they give you a midpoint, they're telling you, well, something's cut into 2 equal pieces. We've got the vertical angles we've seen. We've seen the tough part with the parallel lines cut by a transversal. We're looking for alternate interior or corresponding angles are congruent. And the other one was when we had the angle bisector. Cut an angle into 2 equal pieces. There's 2 little equal angles there. Okay? Good luck. Let me know if you need a little help.